We talked about lymphatic vessels and the flow of lymph, how it all drains back into the blood. Let's start talking about some of the specialized cells of the lymphatic system. So, lymphocytes, again, it's called the lymphatic system because it's where lymphocytes travel and hang out. So, lymphocytes, three main kinds. Natural killer cells, and don't you wish that was your name? Wouldn't that be awesome? When they do that thing where they say, state your name, last name first, you would go killer. Natural. So only 5% of your lymphocytes are natural killer cells. But natural killer cells are ferocious. They're like your body's ninja. We'll see what they do. They're deadly against bad guys. Then you have T lymphocytes, which we normally just nickname T cells. Those are overwhelmingly the largest number, 80%. And then B lymphocytes, or B cells, which are only 15% roughly. I'm going to remind you, you can call them T cells and B cells, but don't forget that they're actually T lymphocytes and B lymphocytes. So T cells and B cells are white blood cells. They're very specialized white blood cells, and they do very specialized jobs. We're going to see that coming up. Then macrophages. We've talked about these before. Remember, monocytes are one of the 5 kinds of white blood cells. They leave the blood and they morph into these giant, horrendous things, macrophages. So they're phagocytes derived from monocytes. So macrophages, macro, big, phage, eat. They are big cells that eat everything and anything. So they eat bad guys. They eat cellular debris. They eat waste products. I mean, they're just giant cleanup machines that both kill bad guys by eating them, and they also clean up whatever mess is there. So like after, remember, neutrophils are one of the first ones on the scene to fight the bad guys. And remember, neutrophils are like really dumb soldiers with powerful weapons, and they just kill everything there, including the bad guys and the good guys and themselves. Well, macrophages clean up all that mess. And macrophages play an important role as antigen-presenting cells. This is a huge deal in the immune system, so make a little asterisk by this. APCs, antigen-presenting cells. What APCs do is they eat antigens, or they eat a pathogen, and then they display the antigen. Antigen, we've seen before. Remember, on red blood cells, we had either A or B antigens. Well, antigens can also be part of pathogens. Pathogens are bad guys that invade your body. Antigens, the word comes from antigen, antibody generator. So antigens are things that cause you to make antibodies. They're basically the molecule that alerts your immune system, and that your immune system can recognize to know that a bad guy is here. So what the APCs do, they can eat bad guys, and then they display the antigen on the cell surface. And that's a way of alerting the rest of the immune system of exactly which bad guy has invaded us. So an APC could eat measles, or it could eat strep throat, or it could eat, whatever, hepatitis. And then it will show it on the surface of the cell, and then your whole immune system will go, oh my God, we've got strep throat. Oh my God, we've got a coronavirus, all right? So APCs are crucial to the functioning of your immune system. They alert the specific immune system, all right? And we'll see, we have what's called the innate immune system and then the specific or adaptive immune system. And APCs are particularly useful in alerting the specific or adaptive immune system. There are other APCs, dendritic cells, and you've seen these before. Remember in Bio 201? The old name for them was Langerhans cells. Technically, all eponyms are out in science and in medicine, and so we should call them dendritic cells now. And then B cells. B lymphocytes can also function as APCs. So there in the bottom left, you can see there's a natural killer cell killing a target cell. And then here in the bottom right, you see the APC targeting technology there. You see the APC, basically you see the antigen. So the APC is going to eat that antigen, and then it's going to show part of it to a T helper cell. That's a very important thing to do, okay? So those are lymphatic cells. Let's talk about lymphatic tissues. We have what are called diffuse lymphatic tissue. Diffuse means spread out. So not all in one place, spread out and all over the place. So these are scattered lymphocytes all through your body. Lymphocytes here and there, just everywhere through your body. There are specific kinds called MALT, mucus-associated lymphatic tissue. So what's going to happen here? Think about the entrances to your body, your mouth and your nose. There's mucus tissue in your nasal and oral cavities. Think about on the other end. Your GI tract, by the way, is a 30-foot long tube with mouth on one end, anus on the other. Think of inside of the anus, in the rectum, there's a mucus tissue in there as well. Think about your urethra, your vagina, if you got one. There's mucus tissue in there. Mucus, as it turns out, is kind of like a sticky trap for bad guys. Bad guys get slowed down in mucus. So what does your body do? It has mucus tissue guarding the entrances to your body, and then there are lymphocytes hanging out in there. So when the bad guys get bogged down, the lymphocytes can kill them. So two main kinds of MALT. We have BALT and we have GALT. So BALT is bronchial-associated lymphatic tissue. That's what lines your respiratory tract. And GALT is gastric or gastrointestinal-associated lymphatic tissue. That lines your digestive tract. So you've got the Malt brothers, Balt and Galt. Balt, Malt, Galt, Malt, Balt and Galt, Malt, the Malt brothers, all right? Guarding in the lymphatic tissue, lymphocytes embedded, guarding the entrances to your body, trying to get bad guys on the way in before they get any further. Then we have what are called lymphatic follicles. Now, you can call them lymphatic nodules, but I highly recommend that you don't. Because if you do, you're going to get mixed up and you're going to think they're the same as lymph nodes, and they're not. A lymphatic nodule and a lymph node are completely different things. So that's why I say don't even get there. Don't even go there. Don't get lost in that crap. Call them lymphatic follicles, okay? So these are dense oval-shaped structures. They have no capsule, meaning they have no covering that goes around them. And they're chock full of lymphocytes, okay? They can stand alone or appear in clusters, or appear inside of other organs, like lymph nodes, tonsils, appendix, and spleen. So in the lower left, there you see a cutaway of some intestinal tissue, and they have what are called Peyer's patches. Peyer's patches are simply lymphatic follicles that are in the intestine. Doesn't make sense. The intestine, remembers, where you're digesting food and absorbing nutrients into your body. Well, what if there was bad guys on the food you ate? What if they made it that far? Yeah, so you've got these lymphatic follicles down in your small intestine full of lymphocytes ready to kill bad guys. And then in the lower right, that's a lymph node, the whole big giant green thing. But notice inside the lymph node there are all those little purple blobs. Each one of those is a lymphatic follicle, all right? So what's going to happen here is as lymph passes through the lymph node, there are lymphocytes in the lymphatic follicles that are basically just going to be surveying the fluid coming through. Kind of like, when you come back from Mexico and you have to stand in line and then go through the turnstiles and they say, state your country of origin, the contents of your bag, and you go, yeah, I'm from the USA and I've got some huaraches and I've got a velvet Elvis painting and I've got some candlestick holders, and the other people in line are just going like, oh, for God's sakes. Whenever I do that, they say, state your name, contents of your bag. I say I'm from the United States of America, and I've got typical tourist crap. And they just wave me through. You don't have to itemize it, for God's sakes. But at any rate, those lymphatic follicles full of lymphocytes, and what they do is they're watching stuff coming through those lymphatic vessels entering. And if they see regular old things, nutrient stuff, they just say, hi, how are you? Nice to see you. How's it going? If they see a bad guy, they pull out the Glock 9 right there. No arraignment, no handcuffs, no take them down to the station. No, they don't get to call a lawyer. You don't read them their Miranda. You just kill them right on the spot. Your immune system is badass, okay? So lymphatic follicles full of lymphocytes. All right, so remember the difference. Lymph node is the entire big green thing there. Lymphatic follicles are the little purple things inside. They're totally different. Okay, lymphatic organs. All the way up now we did lymphatic cells, we did lymphatic tissues. Let's start talking about lymphatic organs, okay? So we have what are called primary and secondary lymphatic organs. Let's look at primary first. Primary lymphatic organs are where B and T lymphocytes become, the word is immunocompetent. What we're going to see coming up is that when you're born, your B and T lymphocytes don't know yet who they're supposed to watch for and kill. They have to go through training, kind of like boot camp. So they go through boot camp in the primary lymphatic organs, okay? So B cells go through boot camp in the red bone marrow. Think of B for bone. That's not actually what B stands for. I've looked it up like 11 times. I can't remember. I think it's a German word, but I just remember B is for bone. So B lymphocytes get trained. They go to school. They go to their special ops training in the red bone marrow. Whereas T cells, they get their training in the thymus gland. You didn't even know you had a thymus gland, did you? It's sitting up on top of your sternum. As we'll see, it's huge when you're first born, but it shrivels up and turns like practically nothing by the time you're the age you are now. So there was the primary lymphatic organs, only two, red bone marrow, thymus. Then there are several secondary lymphatic organs. So your tonsils, there you see in the lower left, somebody with some big swollen tonsils there. Those are what we call the palatine tonsils. They're back by your palatine bone. So tonsils are lymphatic organs. Lymph nodes. And lymph nodes, their job is to filter your lymph. The fluid passes through lymph nodes, and that's where we filter it, looking for bad guys. You also have the spleen. Remember, the spleen is where you recycle red blood cells. Well, you see, as long as the red blood cell, so a lot of blood passes through the spleen, and as long as we're taking the time to, check out the red blood cells and get rid of the old defective ones and recycle them, what the heck? Let's check for bad guys at the same time. So the spleen filters your blood, but then you have lymphatic tissue in the spleen that's ready to kill any bad guys that are there, all right? So just remember, secondary lymphatic organs, tonsils, lymph nodes, spleen. Lymph nodes filter lymph, the spleen filters your blood. So let's take a look at the red bone marrow. Remember, this is where hemopoiesis for all blood cells takes place. You make red blood cells, white blood cells, and platelets, megakaryocytes. You make all of that in the red bone marrow. Red bone marrow contains fat reticular cells developing blood cells and blood sinusoids. So remember the sinusoidal capillaries, big giant capillaries where you get red blood cells in and out. This is where the B cells, the B lymphocytes, become immunocompetent. This is where they learn. What we'll see is that every pathogen has a B lymphocyte assigned to it. So like, polio. You have a B lymphocyte that's just for polio. You have another one that's just for diphtheria. You have another one that's just for the measles. So in other words, the B cells have to be trained how to recognize their particular bad guy. And that training takes place in the red bone marrow. And then the thymus. There you go. There's the thymus right up on top of your sternum. Notice that in a newborn, it's massive. Look at how huge it is in a newborn. Look, by the time you're an adult, it's this little shriveled up thing, not nearly as big anymore. So it's a bilobed gland, has two lobes in the superior mediastinum. You know where that is, between the sternum and the aortic arch, all right? It's very large at birth and continues to grow until adolescence. Then it undergoes involution, degeneration, and infiltration with fat during adulthood. So basically, the working cells kind of go away, and then you fill it with fat cells. Why is that the case? As I'm going to keep reminding you, your specific or adaptive immune system has to get trained during childhood. By the time you're an adult, most of the training is already over with. Have you noticed how little kids, seems like they've always got a fever, they're always sniffling, they're always sneezing and coughing, and they got sinus drainage, and they're puking, and they've got diarrhea, and God, they're just a mess, aren't they? What's going on is during childhood, as they're encountering the bad things in the world, the immune system is going to war against them and winning for the most part, and then the immune system remembers, all right? Your immune system remembers, and that's why you don't get sick with those things when you get older. So like when I was young, I got the chicken pox. Well, I don't have to worry about the chicken pox anymore. I'm now immune to the chicken pox. That's because my immune system learned about it, and it won't let it in anymore, all right? Or it kills it the moment it gets anywhere near me. So the thymus, again, this is where the T cells, the T lymphocytes, get trained throughout childhood. That's where they develop, and the term is immunocompetence. They now know how to recognize their bad guys. So what I was just saying about B cells, true for T cells as well. You have a specific T cell for strep throat. You have another one for hepatitis, another one for the measles, you have another one for the mumps, all right? Another one for hepatitis A, another one for hepatitis B. You have a specific T cell for every possible bad guy that there is. But they don't know how to recognize them when you're born. They have to go to school. They have to go to special ops training, and that takes place in the thymus for T cells. And it's also an endocrine gland. It has hormones, thymosin, thymopoietin, and thymulin. Those are really all involved in training the T cells, okay? And there you see an infant thymus versus an adult thymus. Look at the difference in size. And then in the adult, all those adipocytes. It's all been infiltrated with fat cells. Whereas in the child, it's ready to learn about the world, all right? Okay, these make up the overwhelming majority of your body's lymphocytes. Which ones were they? Do you remember? Yeah, T cells, roughly 80%. B cells, 15%. Natural killer cells, 5%. Neutrophils and immunoglobulins are not lymphocytes, okay? And this is kind of a funny thing. My friend Lee, she's former student of mine, and I used to see her at the gym all the time. It was cool. I saw her a lot. Over a period of several years after she was out of my class, I continued to see her. She went to nursing school, made it all the way through, did very well. And then she decided to become a nurse practitioner. And it was funny because she texted me this just out of the blue one day. She said, I want you to know that I still think about the Pope's hat when I think about the mitral valve. I imagine a little Pope's hat sitting at the entrance to all of our left ventricles, and there's never any doubt which one the mitral valve is, the tricuspid or bicuspid, because Tom told me a long time ago it looks like a hat. Taking my boards in 1 hour. She's taking her NP boards in 1 hour, and I said, girl, you are such a star. Suerte. And then she posted just a little bit later, official announcement passed. I'm now Dr. Kaya Lee Delamo, DNP, FNP, board certified, baby. Yahoo! Never want to forget what the computer screen said. You have completed your exam. Well done. You passed. Your score is passed. Lee is awesome. She's moved out of the Tucson area now, so I don't get to see her anymore. But look, you guys, it can all come true. She is such a damn star. She worked very hard, and she got there. Okay, so more about secondary lymphatic organs. Here we go. Tonsils. So they're partially encapsulated. So they kind of have a covering around part of them, but then they're open. And they're open on the end where bad guys would get in. So they guard your throat there. Those are the palatine tonsils. You also have what's called the pharyngeal tonsil. Its nickname is the adenoid. So you see that in that illustration on the right. Its more proper name is pharyngeal tonsil. And what tonsils do is they have crypts in them. Crypt, like an underground passage, all right, like a tomb. So the crypts are basically traps. So they're located in mucous membranes that protect your throat. The idea is as you're swallowing food, there might be bad guys on the food, pathogens. So your tonsils are trying to catch them before they go down. So the palatine tonsils are trying to guard the throat, the oropharynx, whereas the pharyngeal tonsil, the adenoid, that's up where your nostrils come in. So it's guarding what we call the nasopharynx, your nasal cavity, all right? So you've got a tonsil for stuff coming in through your nose, and you've got two tonsils for stuff going in through your mouth, all right? See, they're guarding you from having bad guys get in. They contain lymphatic follicles full of lymphocytes ready to kill the bad guys. Remember, they don't arrest them, they don't question them, they don't arraign them, they get no Miranda. They are executed on the spot, all right? And then lymph nodes as well. What do they filter? They filter lymph. And the spleen, what does it filter? It filters blood, okay? So there you see in the illustration on the left, lots of lymph nodes all through the body, and then the spleen over on the left side of the abdominal cavity. And here you see the tonsils. There you go. And see how the tonsil illustration on the right-hand side. See the crypts? See, what happens is those long tunnels, and so bad guys, if they make it this far into your body, they go, ooh, that looks cool. I wonder what's down there. And they walk down the end of the crypt, and what do they have waiting for them? A lymphocyte carrying a Glock 9, or maybe a Smith & Wesson, maybe a Beretta, whatever you want. Then, right on the spot. They're dead. They don't go any further. So you have one pharyngeal tonsil, also called the adenoid, and you have two palatine tonsils that guard the throat, and then you have a whole bunch of tonsils on your tongue. Those are called the lingual tonsils. Those are smaller, and you've got bunches of them, okay? And here's my former student, Karen, and when we were talking, she was in my 202 class, and 201 as well, but in my 202 class, when we were doing the tonsils, she said that she had tonsillitis, and she was getting her tonsils taken out as soon as the class was over, as soon as the semester was over. And I said, awesome, I want to get a picture of your tonsils. So she said, okay. So there you can see I got the green arrow pointing. See the big, giant, enlarged tonsil? And there's one on the other side as well. You can look for that. So that was so cool of Karen, letting me take a picture of her tonsils. So, and there's Cassie on the left and Karen, both in my 202 class several years back. So awesome. Both of them painted my fingernails for me. That's one of the things I miss about being in the classroom. That's one of the things about the pandemic that sucks. I'm not getting my fingernails painted anymore. Karen and Cassie both did such a great job at painting my fingernails.